I would say that once a decade or so, astronomers discover a new type of mysterious event. For example, in the history of astronomy, pulsars were an unexpected mystery, gamma ray bursts were a mysterious surprise, and so on. And the 21st century mysterious surprise is the fast radio burst, which is some sort of very energetic event that happens at a great distance that we observe here on Earth as a brief pulse of radio waves coming from very far away.
Fast radio bursts are a really exciting mystery. We have more ideas of what they could be than we have actual detected fast radio bursts. So the CHIME telescope doesn't look like you might expect a telescope to look like. The physical telescope has no moving parts. It has these cylinders that are 20 meters wide and 100 meters long, so the collecting area is huge. That's one of the great benefits we have.
The cylindrical design of CHIME means that we see a stripe on the sky, and as the Earth rotates, that stripe sweeps out the whole sky every 24 hours. I think we're doing something really new with CHIME, which is figuring out how to scale the computations that are needed to do radio astronomy up to unprecedented volume. The fast radio burst search that we wrote here at Perimeter Institute is something like a few hundred times larger than the searches that have been done to date. We have, for example, the highest discovery rate for fast radio bursts of any telescope, but we get it by generating an avalanche of data. We have about 100 times more data than a typical radio telescope, and the computational challenges are immense.
So this was a huge challenge, and one that hasn't really been attempted before, a real-time streaming fast radio burst detection system. And so it's really a pathfinder or a leader in this area. In the CHIME fast radio burst system, we look at every bit of data once, and a second later it's gone. So building this system was a real challenge and a real different sort of software beast.
Throughout the first few weeks of our FRB search, we were finding fast radio bursts at the rate of one FRB every 2 days or so. That's actually a really impressive number, since the total number that were ever found since the initial discovery in 2007 is around 50. In the first few weeks of our search, we found a new repeating FRB. Prior to that, the situation was that about 50 fast radio bursts had been observed, ever, and one of them was a repeating fast radio burst. The other 49 had not been observed to repeat, despite a lot of telescope time spent looking, and that was a real mystery. So what we've shown is, by discovering a second FRB, is that the repeating FRB is not unique, and maybe we can hope to find more.
So with these two new papers, what the CHIME Fast Radio Burst collaboration has shown is that, well, a few things. The CHIME FRB instrument works, and we're finding fast radio bursts. The 13 we report in this paper were found during our kind of pre-commissioning phase, when we were basically turning the system on for the first time and determining whether it worked or not.
It's very interesting that it really is one of the most powerful radio telescopes in the world, and we've made it work through new software and new computing techniques that were really developed here in Canada for the project. And so it's very exciting that Canada is really leading the world in this particular part of astronomy.